This is Mrs. Ward. I'm going to go over the 10-6, 10-8 review worksheet. So the first thing I'm going to do is it says make a table for the parametric equation, then sketch the curve. So remember so I'm going to have t, then I'll have my x, then I'll have my y, and since it's trig, I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. For x, I'm doing 3 times the cosine of t. So the cosine of 0 is 1, so this will be 3, 0, negative 3, 0, and 3. The sine is 5 times the sine of t, so this will be 0, 5, 0, negative 5, and 0. Applying those points, I'm going to plot 3, 0, then 0, 5, negative 3, 0, 0, negative 5, and then be back up here. So I'm going to have this ellipse, and then for parametric, I have to remember to put the directional angles that this ellipse goes in, and that's based on the that I graphed. Okay, number 2 is the same thing. I'm going to make a chart. This is not trig, and it gives me the interval from negative 3 to 3, so that's the numbers that I'm going to use. So x is equal to t, so that's easy. And then for y, I'm going to have t squared, so this will be 9 over 2, 4 over 2, which is 2, 1 over 2, 0, 2, 4 over 2, and then 9 over 2. So when I plot this, I'm going to have negative 3, 9 halves. I'm going to have negative 2, 2, 0, 0, positive 2, 2, and 3, 9 halves. So it's going to be a parabola, and the direction is going to be that direction. Again, that's the way I graphed. You do not put the arrows here because they want you just to do the interval from negative 3 to 3. Then the next one, we want to obtain eliminate the parameter, so we're trying to get rid of the x. So I'm going to take this equation because it's the easiest one for me to solve for x. I'm going to have x minus 2 is equal to negative 2t. Divide both sides by negative 2. I'm going to t is equal to, I'm going to write 2 minus x over 2. Then what I'm going to do is I'm going to put this, whatever t is, into this equation here and solve for y. So y is equal to 4 times 2 minus x over 2 squared, and this is all over 3, minus 4 times 2 minus x over 2, and then minus 8 over 3. So when I do this, I'm going to square this. This will be 4 minus 4x plus x squared over 4, and this is being multiplied by 4. Minus here, the 4 and the 2 will simplify, and I'll be left with a 2, but I'm really a negative 2. So I'm going to make this plus since I'm distributing that negative. Make this negative 4 plus 2x. This is all over 3. And then minus 8 over 3. Here, the 4's will simplify. I notice that I have a common denominator of 3. So I'm going to make this 4 minus 4x plus x squared minus 4 plus 2x minus 8 all over 3. Combining like terms, I get x squared minus 2x minus 8, and this is all over 3. And now I've eliminated a t, and I'm just left with x and y, so I have eliminated my parameter. The next one is a trig function, so I'm going to bring that down. Hold on. So what I'm going to do is I'm going to take the equation that has t in it, and I'm going to solve for either x or y, whatever it happens to be. In this case, it's x. So I'm going to say t minus 1 is equal to negative x over 3, and then multiply both sides by negative 3. I'm going to have negative 3t plus 3 is equal to x. And that's one of my equations. Parametric equations, I have to have two equations. So that's going to be one of my equations. Then I'm going to use this for x to put it in here to find out what y is equal to. So I'm going to say y is equal to a negative, and then I'm going to do this negative 3t plus 3 squared over 6. And then I'm going to FOIL that. So I'm going to have y is equal to a negative 9t squared plus 18t plus 9 over 6. You should simplify a little bit. Can we simplify it a little bit? So I'm going to factor out a 9. So negative 9, and then this will be t squared plus 2t plus 1 over 6. And then these two can simplify. So y is equal to negative 3 times t squared plus 2t plus 1 all over 2, because it's divide both of them by 3. And so my answer is going to be this for at y, and then x is equal to negative 3t plus 3. So I have to have both of those equations for my answer. Okay? Okay, number 6, when I look at that one, it's probably going to be easier for me to solve for y. So I'm going to say t plus 1 is equal to y over 2. Multiply both sides by 2. And I'm going to get 2t plus 2 is equal to y. Now I'm placing this in for this y here, so I'm going to say x is equal to 2t plus 2 squared over 3. So x is equal to 4t squared plus 4t plus 4 over 3. I don't think that I can oh, this is an 8, my bad, 8, 8, 8, 8. Can't simplify that anymore, so that's my first equation. My other equation is going to be that 2t plus 2. And so my final answer are those two equations. Okay, number 10, it wants me to convert each pair of rectangular coordinates to polar coordinates. And then it wants me to find the plot it and then find the remaining points. So this is a polar point. No, I'm sorry, this is a rectangular point. So this is my x and this is my y. So I'm going to say r squared is equal to x squared plus y squared. So r squared is equal to 1, r is equal to 1. To find my angle, I'm going to say the tangent of theta is equal to y, which is 0, over x, which is 1. And I believe I get 0. So my one polar equation is going to be 1, 0. Plotting that, 1, 0. Now I want to represent this point different ways. So the other way I can do it is I can leave it 1 and then just add 2 pi. So 1, 2 pi. Then I can use the angle pi and just make that radius negative. And those are the 4 ways that I can write that ordered pair. And now I have the ordered pair on negative square root of half, so I'm going to say square. So when I do that, I end up with 27 fourths. Yeah. 36 fourths. I would want that. My y. Go ahead. I got to about it. Oh, you're all right. It's all right. Point. Now I get that. I have to try to fix that in the first part. This component pair is in the third part. So I can either use that higher 6, because I want to use the first part, I can make that negative. Okay, for number 12, the biggest mistake people make with number 12 is I've got to remember my directions. My directions are saying convert each equation from rectangular to polar. So this is rectangular. I want to go to polar. But as soon as you see the x squared and y squared, you kind of want to do the sine squared plus cosine squared thing, but that's not what this one's doing at all. This one wants me to get rid of the x and y's and replace them with r's and thetas. So what I am going to do, I find it much easier if I square both binomials. So I am going to square, I'm going to square this and have x squared minus 6x plus 9. Square the next one, plus y squared plus 2y plus 1 is equal to 10. Then I am going to know, I'm going to rewrite it in a way that makes sense to me to do change rectangular the polar. So I'm going to say that x squared plus y squared minus 6x and then plus 2y, and then the 9 plus the 1 will be 10. So I'm going to subtract 10 from both sides, and this will be equal to 0. Then x squared plus y squared is equal to r squared. And then in place of the x, I'm going to write r cosine theta, because x is equal to r cosine theta, and then plus 2, and then r sine theta. And this is all equal to 0. So then what I'm going to do is I am probably going to put everything on one side, and I'm going to leave this r squared on this side. Then for some reason I put these two on the other side. I'm not sure why I did that, but I did. So I'm going to have 6, I'm going to r cosine theta plus 2r sine, oh, that's minus sine, 2 sine theta. There's an r in there. So I am going to say r squared is equal to, here I can factor out an r, make it r times 6 cosine theta minus 2 sine theta. And I am going to divide both sides by r. And I'm going to end up with r is equal to 6 cosine theta minus 2 sine theta. And I don't think that I can simplify that any further. I'm just doing a double check to make sure that I eliminated all my x's and y's, and I'm left with r and cosine. So yes, that's good. Just make sure you don't have an r on both sides. That's not needed. All right, the next one I have 13. 13 is still the same directions, I believe they are. So I am going to square x squared plus 2x plus 1 plus y squared minus 4y plus 4 is equal to 5. Putting the x squared and the y squared together, plus 2x minus 4y, and then the 1 plus the 4 will be 5. Subtract 5 from both sides, and it's equal to 0. This becomes r squared, and then I'm going to have plus 2r cosine theta minus 4r sine theta, because that's what x and y are equal to. I am going to say r squared is equal to a negative 2r cosine theta plus 4r sine theta. I'm going to decide to divide everything by r. I could have factored out the r like I did in the previous problem. R, simplify the r. I'm going to be left with r is equal to a negative 2 cosine theta plus 4 sine theta. Problem, I'm probably going to get rid of the 4 in the denominator, so I'm going to multiply both sides by 4. And when I do that, I'm going to have 4x is equal to y squared. I'm going to replace the x with r cosine theta. I'm going to replace the y with r sine theta, but that's squared, so I'm going to write squared. So this will be 4r cosine theta is equal to r squared times sine squared theta. Probably, to make life somewhat easier, I'm going to divide both sides by r. And when I do that, I'm going to have 4 cosine theta is equal to r times sine squared theta. I want r on one side by itself, so I am going to divide both sides by sine squared. And when I do that, this will just be r, this will be 4, and then I'm going to have cosine theta divided by sine theta times 1 over sine theta. That'll give me that sine squared theta. So r is going to equal 4. Cosine over sine is cotangent. 1 over sine is cosecant. So r is going to equal 4 cotangent theta cosecant theta. Number 15, I'm trying to convert each equation from polar to rectangular. So now I'm using the fact that r sine is equal to y and r cosine is equal to x. I'm also, the one I do not want to forget that a lot of people forget, and it kind of makes me sad, is don't forget that the tangent of theta is equal to y over x. So on this very first one here, I'm going to leave this r here for a second, and I'm going to write 3. This tangent is y over x. And I'm going to write that because that's what it's equal to. Secant, I remember, is 1 over cosine theta. So when I'm going to simplify this, I'm probably going to multiply both sides by cosine of theta to get that cosine out of the denominator. I'll fix the rest in a second. So I'm going to have r cosine theta is equal to 3, can I write 3y over x? I'm going to. All right, so r cosine theta, that turned out nice. That's equal to x. I'm going to have x is equal to 3y over x. Multiply both sides by x. So x and x, to get rid of that x in the denominator, I'm going to have x squared is equal to 3y. Solving for y, I'm going to have y is equal to x squared over 3. And that's my rectangular equation. I got rid of my r's and my thetas and replaced them with x's and y's. So number 16, I'm going to leave the r here for a second. Oh, I have to somehow get rid of my r's, and I'm going to ask myself, well, what's the best way to do it? I can either square that r, or I can multiply both sides by r. And seeing how I have trig functions on the other side, I'm probably going to decide to multiply both sides by r. So r times r will be r squared, and then this will be equal to negative 4r cosine theta minus 4r sine theta. Now I can make the r squared x squared plus y squared. The 4 is equal to, this will become x, so this is minus 4x. And then this will be y minus 4y. So I'm going to write it as an equation of a conic, so I'm going to bring these two over to the other side. So I'm going to have x squared plus 4x plus y squared plus 4y, putting my x's together and my y's together. Again, writing it as a conic, I'm going to complete the square. So when I complete the square for x, I'm going to ask myself, what is half of 4? And you're going to say 2. And what is 2 squared? You're going to say 4. I'm going to add 4 to this side, which means I have to add 4 to the other side. Completing the square for the y's, I'm going to take half of 4, which is 2. 2 squared is 4, so I'm going to add 4 to this side, add 4 to this side, and I'm going to get 8. This is a circle. It is a circle because both A and B are going to be the same. You can leave it like this because it is a circle, or you can divide it by 8. Either one is acceptable, but you guys are so used to setting everything equal to 1 that that is fine. So I'm going to have this plus y plus 2 squared over 8 is equal to 1. I know it's a circle because these two, my A and my B, are the same. So either way is fine. It's up to you. Okay, the next one, number 17. I am going to decide what I'm going to do with that r. I think I am going to multiply both sides by r again. And when I do that, I am going to have r squared is equal to, going to do r cosine or cotangent. Can I want to. I'm going to make cotangent cosine over sine times 1 over sine theta. And this is all times r. Yes, yes, yes. So when I do that, I'm going to have r squared is equal to r cosine theta over sine squared theta. Getting rid of the sine squared in the denominator, I'm probably going to multiply both sides by sine squared. So I'm going to have r squared times sine squared theta is equal to, and then r cosine will just be x. I can think of this as r times the sine of theta, and that whole thing is squared, is equal to x. So this r sine is going to be y, so I'm going to have y squared is equal to x, and I would probably just leave it like that. That's one way I could do it. You know, there's so many ways I can do this. So I'm going to copy that one down again. That's r. I'm going to show you a different way. Up to you, as long as you show me the work that you're doing, we're good. So r is equal to cotangent theta cosecant theta. I mean, let's just leave cotangent like that for a second and say cotangent theta, and then this is 1 over sine theta. If I do that without multiplying by r first, I would get rid of that sign in the denominator by multiplying both sides by sine. And when I do that, r times sine will be y. So I have y is equal to cotangent. And do we all agree that cotangent is 1 over tangent? Well, you're not here to disagree with me, so I'm going to say yes. So I'm going to say y is equal to 1 over, the tangent is y over x. So if I wanted to get rid of that in the denominator, I would multiply both sides by y over x. Whoopsie. Where'd it go? I multiply this side by y over x. I'm going to multiply this side by y over x. And I'm going to have y squared over x is equal to 1, which if I multiply both sides by x, I'm going to get y squared is equal to x. Either way is fine. Both ways are legit. It's just a matter of what you're more comfortable with and what makes more sense to you. Number 18, I'm going to multiply, baby one, multiply both sides by r. And when I do that, I'm going to have r squared is equal to negative 6r cosine theta. So that r squared becomes x squared plus y squared minus 6x, or is equal to negative 6x. So I'm going to have x squared plus 6x plus y squared is equal to 0. Completing the square, I am going to have x plus 3 squared. 3 squared is 9, so I'm adding 9 here, which means I have to add 9 here. Plus y squared is equal to 9. Again, it's a circle, so I can leave it like this, or I can divide everything by 9. And when I do that, I'm going to get x plus 3 over 9 plus y squared over 9 is equal to 1. Either answer is correct. Okay, now we're getting into the graph. So given the equation, and the directions for on the test are exactly like this, It says, given the graph of the equation, the rose curve, determine if the graph is symmetrical with respect to the origin, polar axis, or line if theta is equal to pi over 2. So since this is a sine curve, I know that it's going to be it's going to be symmetric over the line theta is equal to pi over 2. If I don't know that before I start graphing it, I'm going to wait and graph it and see what happens. Just make sure you answer it. It says find the values of theta where r is 0. So I'm going to set this equal to 0. So 0 is equal to 5 sine 3 theta. Divide both sides by 5. 0 is equal to sine of 3 theta. Then I ask myself, when is the sine equal to 0? And that's going to be 0, pi, and 2 pi. And I'm going to set those equal to 3 theta. And then to find just 1 theta, I divide everything by 3. And so my zeros are going to occur at 0, pi over 3, and 2 pi over 3. There are more zeros, but those are good. That's a good start. And because remember, graphing a 0 on a polar graph does me absolutely no good because it's going to be right here every single time. It doesn't help me whatsoever. The next thing is find the maximum, and it has it in the absolute value signs. Okay, so if I want the max is going to be this number outside, so the max is going to be 5. That's the max. And then it wants to know the thetas where this occurs. So I'm going to ask myself, in order for this to be 5, this whole thing has to be 1. So then I'm asking myself, when is the sine normally equal to 1? And that normally happens when the sine is equal to pi over 2. And so I'm going to set 3 theta equal to that pi over 2. And I'm going to get theta is equal to pi over 6. So my max of 5 will happen at pi over 6. It's going to happen more than that, but that's one place. I'm going to plot that point now. 1, 2, 3, 4, 5. If I knew that it was reflective over the line theta is equal to pi over 2, I could go ahead and graph this point now. this one here, but let's say I didn't know that. Let's say I didn't know that. To do the rest of the graph, you have choices. One choice is that you do a theta and R chart and you start picking values and you start graphing. That's one route. I'm not going that route. The other route is that I know it's a rose curve. This is a 3, which tells me that there are 3 petals. The petals are going to be 360 degrees divided by 3 or 120 degrees apart. Or since I'm in radians, I could say 2 pi, which is 1 unit circle, and divide that by 3. So they're 2 pi over 3 apart. So once I have this first one at pi over 6, to find the next one, I'm going to add the difference. So I'm going to take pi over 6 plus 2 pi over 3, and I'm going to get 5 pi over 6, which is what I was expecting because I knew it was reflective over the line theta is equal to 2. So there's the one. To find the third and final petal max is I'm going to start with this 5 pi over 6. I'm going to add 2 pi over 3 again. And when I do that, I get 9 pi over 6. In lowest terms is 3 pi over 2. And that makes sense because at 3 pi over 2, 1, 2, 3, 4, 5, I'm going to have my other max. And it's reflective over the line theta is equal to pi over 2, which is where it's at. That's why I only have one dot. Then I'm going to sketch my graph. Probably shouldn't have used black, but I did. And there's my curve. Three petals, equal distance apart. And I'm going back to make sure I answered all my questions. And I've answered all my questions. I probably would throw it in my calculator and check it and make sure I did it right. But if you just throw in your calculator, you're not getting full credit. All right, number of 20 is the exact same thing, but it's a cosine curve, and I have 2 here, which means there are 2 petals. But it is a cosine curve. I know cosine curve is symmetrical over the polar axis, which means it's going to be reflective over the polar axis, which is this line here. If I don't know that, again, I'm going to graph it first and see what I get. I am going to find my zeros first. My zeros are going to be 0 is equal to 4 cosine 2 theta. So 0, divide both sides by 4. Now I'm asking myself, when is the cosine equal to 0? And that happens at pi over 2. And it happens at pi over 3 pi over 2. And that's going to equal 2 theta. So to find 1 theta, I'm going to divide both by 2 or multiply by 1/2, and I get pi over 4 and 3 pi over 4. So those are 2 places where my 0 occurs. My max is going to be this number here. So my max is going to be 4. And when does that occur? That occurs when my cosine is equal to 1. Well, when does my cosine equal 1? My cosine is usually equal to 1 at 0 and 2 pi. I'm going to write both. That's just going to help me out. So I'm going to say 2 theta is equal to 0 or 2 pi. Divide both by 2. So theta is going to equal 0 and pi. So I know I'm going to have my max at 4, 0, and then 4 pi. So I am going to sketch those. 1, 2, 3, 4. 1, 2, 3, 4. And those dots do not help me graph the other dot at all because they're on the axis where they're reflective over. So I am going to go back here. This is an even number. If it's an even number, that means that there are 4 petals. My petals are going to be 360 divided by 4 are 90 degrees apart, or 2 pi divided by 4 are pi over 2 radians apart. If I have a 0 at 0, if I have a max at 0, 0 plus pi over 2 will give me pi over 2. So I know that I'm going to have a max here at pi over 2, 1, 2, 3, 4. And then I can reflect this one down here. But if I didn't know that, I would add, if I add pi over 2 again, I'm going to get the pi. Well, I already had that, so that's not very helpful. If I add pi over 2 again, that's going to give me 3 pi over 2, and that's what gives me that fourth and final dot. Then I'm going to sketch my rose curve. So I think I've answered all the questions. Let me go back up and make sure. I said where it was symmetrical. I found the values where I found some values where r is equal to 0. I found the max. I found the values where the max occurs, and I sketched the graph.